right, I'll share my screen.
Yes.
So everybody can see my PowerPoint, my slides.
Yes, I can see it.
All right, okay. Thank you, Evan, for organizing this event. This is really a good event. When you approached me, and I knew this is a good event, so I quickly just passed the message to our IT chapter, and actually Mr. Sufyan is our IT student chapter president, and he agreed with us and with me that this is a good opportunity, and we have several students from University of Alabama also attending this seminar, online seminar, webinar. And all right, and okay, well, I try to make a very good cover of my presentation, but when I try to find logos, I know we have a UTK ITE logo, but we don't have a UA ITE logo. So that may be something we need to work out. To create one, just create one.
Yeah.
I just put, the TSC and the Alabama ITE together. That's representing our UA ITE. Okay.
We need to make one. We'll make a better one. Yeah.
Make a better one compared to UTK.
And then we will make another one. We make that one. Okay.
Okay. Well, a little bit more about me. I grew up in China, and I went to school. My college, the Huazhong University of Science and Technology, in the central part of China. And then I went to University of Knoxville. I got my degree, my doctorate degree in civil engineering and a master's degree in statistics. Where University has a very excellent program that offers kind of free courses for free degree for the PhD students in the computer science, statistics. You just take all those courses, and the university would grant you a degree. So that's really nice. And I spent a couple months, less than 1 year, here at Texas Austin as a postdoc. And then I spent 2 years at Virginia Department of Transportation as a travel demand modeler or transportation planner. That's 2 years in Richmond, Virginia. And in 2018, I moved to Tuscaloosa, Alabama, and became an assistant professor, civil construction environmental engineering at this university. And this is kind of, I say, a picture of a complete picture, not a complete picture, almost complete picture of my research, and including both traditional topics and emerging topics. Traditional topics are just something we always talk about, safety planning and sustainable transportation, some old topics. Emerging topics, that's just hot topics, and everybody's talking about it. And it's just now that's our direction, that's our future research. And all those emerging topics would likely to affect our traditional topics as well, such as the safety. And we just think about it. Currently we know the drivers are responsible for over 95% of the crashes on the road. But if you think about it, in the future we have autonomous vehicles. Okay, who should we blame? So that's we have to change the answers to that same question. All right, I just will go very quick, and this is my Google Scholar page, and I just want to show my co-authors, my advisor, Asad Katak, and my postdoc advisor, Dr. Kara Kokeman, Austin, Texas. And this is also a good friend, David Green. You may know him or you may not know him. And Baram Wali, who is currently at MIT, and Xiaobi Ni is also my fifth top co-authors. All right, how to write a research paper, just some disclaimer. I'm not the expert, and I'm still exploring and growing. I'm trying to learn from many people around me, and the world constantly changes. So people have changed their viewpoints from time to time. So our writing skills, our research topics, our research methods also may need to change. I'm here just to share what I know, and it may be wrong, and just to let me know if you think I'm pointing to the wrong direction. Okay, here we go. Topic selection. This is very important when you kind of make a decision what you are going to write a paper, what study you are going to look into. first question is, are you really interested in your topic? Well, you may not say yes, for all your topics, because we all had that, most of you are currently working with your advisor, and they have a topic for you, and you may just follow your advisor's direction. So sometimes you may have to make yourself interested in what you are doing, and that is because your advisor may have a better sense of what topic is better accepted by the community, research community. You may want to do something, but your advisor may know more about what you are doing, and they know, some topics, some papers, you can sell some papers very easily, but some papers you cannot say that those papers very easily, because people won't buy your papers, won't buy your ideas. So anyway, this is always a way of learning and growing. We are not living a perfect world, and we have to admit that we are living a life, a realistic life. A research paper structure, and I'm not giving you new information. This is basically a very old traditional structure of a research paper, from introduction to conclusions. And I would not encourage you to be creative in having the structure of the paper, since the research papers are, these papers are boring. It's not for you to make fun of writing a paper. Well, if you are writing an article for a magazine, well, that's a different story. Or prepare a presentation or poster, that's a different story. You can make it very funny, very interesting. But writing a paper is very technical and boring. It needs to follow some kind of rules, because reviewers are expecting something. Do you have a good literature review? Does your introduction make sense? If you don't have a literature review, they may say, oh, those authors, they did not, go back to look into all those previous studies. And data, do you have a good introduction with the data, and is the methodology clear and making sense or valid? And the results, are those results supported by the data? And have you provided a very insightful, in-depth discussion about your results? They are always looking for that. Have you, pointed out limitations of your research, and also what are the conclusions? Introduction. I'm just giving some, tips. I got that from Dr. Asad Khatak, and also some of the, points I'm trying to give my students and my co-workers who work with me, writing papers with me. In introduction, you have to be clear about your research questions or your motivation, why you need to do this. I ask that question, are you interested in the topic? You have to make yourself interested. You need to come up with some good reasons why this is a good research, why this is a good topic to, explore. And focused. This is hard. Really, when you write something, it's really hard to focus. Because when you try to focus on the writing on that topic, on one research question, it's not very easy to write. Sometimes you feel like, oh, writing is so easy, I can just write 2 pages, 3 pages for the introduction. Well, if you think that, if you can do that, I'll question you, are you focused? Is your writing focused on what you intended to say? So focused and meaningful. Of course, you have to make sense of what you're writing. And who are concerned with such questions, don't say you are concerned and you are interested in that topic. You should bring that attention to the people who are going to use your results, researchers, practitioners. You have to think about your topic from their side. Motivating the tricky question, that is just you need to convince people why this research is interesting, is unique. And so you have to do some literature review. Make sure the data are not widely explored by other researchers. And the research question is also relatively new, not answered many times by many good top researchers. And also methodology, is it new, innovative, or you are just, using something that has been developed by other people? Well, that's fine. You can apply those methodology. But if a method has been widely used you may need to think about why you need to use the same widely used methods. All right, what do you expect from your study? Expected contribution results. This is something you may also need to ask yourself. Theoretically, can you tell something new from your study? Or methodologically, anything new? Or empirically, anything new? Or practically, anything new? If you can, come up with just one, my research can provide some practical contribution. That's good. If you cannot come up with any contributions, well, that's a question. I'll just say that might not be a research paper. It's maybe a technical paper. It's just you are trying to do something asked by advisor or asked by the sponsor. You are not doing something creative. You're not generating new knowledge. Research review, I just say still be focused. Be focused. When you write, your writing needs to be focused. And always, review good papers from good journals, because reviewers, we always, think us as good reviewers, good researchers. So we put our papers in good journals. So we expect our papers to be reviewed. We don't use to, list a couple of papers from, name journals, and because we don't publish those papers in those journals. So we don't buy the results from those papers. So it's kind of the same thing. If you produce good quality stuff, people buy it. If you get something from good journals, people buy it. People buy what you put in the paper. Show the key results from previous studies. Always show results if you can. And also the results need to be focused, need to be related to what you are writing in this paper. You cannot just say, oh, those bunch of researchers, they have done this, and this study talked about that, and that study talked about that. You cannot just mention that. You have to say, okay, this study has found something that has some influence on your topic. Well, discuss. If you can, try to discuss those papers collectively. Do not simply list them. Do not simply list them. Right now, if you are writing a literature review, if you just write one page or one big paragraph, and you go back to read your literature review, if you find that your structure of writing is similar structure, every sentence, every couple of sentences, they are following the same structure. Authors found something. Authors did something. That is similar structure. If you find that, it's better to have a table to summarize them, to provide a structured results. That helps. The reviewers would appreciate that. And at the end of the literature review, you have to show the gaps. Well, there are many gaps in the existing literature. You have to show the gaps that are related to your research. If you point too many gaps that are unrelated to your research, that's distraction. If you point out that, if I'm the reviewer, are you answering those questions? Are you filling up all those gaps? If you are not doing it, that's not your place to criticize those studies. You can only criticize studies or point out the gaps that you can fill. Well, if you are a big expert, of course, you can point out any gaps you want to. Well, be nice and reasonable. Don't say they are not doing a good job. You may say that, oh, they may ignore, or maybe their focus is not on that. Just in a nice way to address all those. When you identify the gaps, when you identify the problems in the previous studies, because those papers may be reviewed by the authors of previous studies. If you say bad words in your paper about their study, well, that's just a very red flag. A methodology. You may not be very clear about what you want to do the study, but you need to be clear when you finish your paper. When you are clear, you try to, if you can, try to create this kind of conceptual framework to tell the reviewer very clearly what you are doing. They don't have to read your wordy statements. Then they can get a very basic sense of what you are doing. They can grasp the most important of your methodology. So this is, it's hard. Conceptual framework is hard, but it will, it will be appreciated by the reviewers. The reviewers can very quickly get what you intended to express in your writing. And methodology, this is basically only for the data-driven research, because there's another, several other types of research like algorithms. The algorithms, those mathematical problem, mathematical research or simulation-based research. They may have different methodology. You may not follow. What I'm saying here for those kind of studies. If you're doing your simulation, if you're doing a kind of mathematical computation, developing some algorithms. Modern approach selection. You need to be clear about your data structure. Is it a hierarchical structure? What attributes do you have in your data? And also, what is your research question and what are the objectives? Are you planning, are you aimed to do something about prediction or estimation? That's different. For prediction, we pick different models. For estimation, we pick some other models. And if you intend to interpret the results in a very meaningful way, a very clear way, intuitive way, that means you are doing something about estimation. You are trying to estimate the relationships between factors. Prediction is you are trying to predict the outcome based on the factors, the information you are given. So that's the prediction and estimation. So variable selections, also research question objectives. If you are trying to answer a question like whether females or males are, more likely to be involved in speeding crashes, then the gender is a very key factor. You have to include this factor in your model. And also plus some key variables that are often modeled by other researchers, because as a reviewer, I care the factors that I include in my models or whether those variables are also included in your models, because I know the directions, the relationships between those variables with the outcome, crash frequency or the crash interseverity. I know the relationships. If your model has those variables, I can very quickly to tell whether your model is valid. All right, literature review can provide you a list of variables that are often included by other researchers in their models. Okay, data collection, pre-processing. Do you need to collect data for your study? Well, sometimes it's very expensive to collect data, and we often just use the data we can get from websites, from online websites. I did collect some data from the driving simulator. I'm not sure the room number in the Tico building, John Tico building. Anyway, I'm not sure who is using that driving simulator right now for doing research, not just for fun. Is your data ideal for your study? That means, do the data include the key variables you are interested? Always work with good people to get good data, because, like advisors, they know where you can get good data. They know the issues with those data, so they can, they can help you avoid getting in trouble with those data. And extensive data processing requires program knowledge. Well, I tell my students too, even though we are not in computer science department, this is civil engineering or transportation engineering, we still need to know something about coding, programming, because the data processing requires that. And if you have a plan to improve your research skills, try to start with improving your coding skills. Data processing, just data cleaning, need to make sure you are not including any error or wrong observations in your analysis or modeling. Integration, putting data together, do it properly. And visualization. When you're trying to explain something, show something, you say, you may have a long paragraph to show the attributes of the data or something. You want to highlight something. You can write words, statements, and phrases to describe it. But if you can create a graph to show it, that is much helpful. That will just brighten your paper. And also, if you can put data in tables, that's also a very nice way. I mean, some people just use, I don't know, they just use really wordy statements, describe the data, the attributes. Well, you can just use a table actually. This is really, visualization and using tables that really help you a lot if you think you are not a very good English writer. I'm saying this is because I work with some undergraduate students. They are native speakers. Their English is really good, but they don't have some visualization skills yet, or making data in a very structured way. They just use wordy statements to describe what they want to see and what they want to show. But well, I do not encourage you to do the same way. If you can use graphs or tables to show the results, anything you want to show, that's really helpful. That will make your paper look different from other papers. Data analysis, modeling packages. You need to familiarize yourself with those. If for you students at your Tennessee, if you are taking the courses from statistics department, I think you are going to learn all those, the SPSS and data, or maybe not data because data is not free for Tennessee students, and JUMP and SAS, and different professors use different software packages to do the lectures to teach. Again, variable selection, this is basically in the process of modeling. Model choice, ordinary, mixed, square, logistic, multi-level, really depend on the data nature. If the data is the order data, that's order model. If it's multi-level, it's some structures. You have to at least think about multi-level. And also need to be sure that your model can answer the question you want to answer, the question you raised in the introduction. Results, data-driven research. I just show a p-value smaller than 0.05. There's a lot of problems with this p-value, but we are not here to argue about this kind of p-value. The problem with p-value. Always do descriptive statistics. What are descriptive statistics? Mean, standard deviation, and mean, max. Why? It's because showing that can tell the reviewers very quickly whether your data are valid. If you don't show that, I cannot tell whether you are using the right data. For example, if you are showing the percentage of the drivers in your data, if you're showing something, males account for 9%, I may question you why, because our population is just half and half. If it's close to 50%, the data is valid. Or except that you are, well, I don't say an inspection, except your research is focused on male drivers. You are only focused on the male drivers. Regression models, coefficient, I just show it. Coefficient, standard error, t-ratio, p-value, or margin effects. If you can get all that from the statistical packages, put it there. And model summary statistics, number of observations, R-square, log likelihood. You may not fully understand what do they mean, but you need to show them. And you may ask the advisors to explain that to you. And later you will understand it, because reviewers need to say whether your model is valid. If your model is not significant, if you get like R-square, there's R-square less than 0.1, that means you are explaining just less than 1% of variation in the data. That means your model is really trivial. It's nothing. Something less than 1%, we can just ignore. That's a very small probability event. All right, model interpretation. I just show here, be focused, really focused. Some models have long list of variables, 20, 30 variables. You don't have to explain every variable in the results. Just focus on the variables that help you answer your research question. And there's a bad example is many factors are correlated with response, age is statistically significant, gender is statistically significant, vehicle type is statistically significant. Here, what I mean is show the direction of the relationship. Don't just say this is significant, that is significant, that is significant. Well, we know that is significant from previous studies. We don't need you to tell us, but you can show the direction. Males are more likely to be involved in what? Vehicle type, SUVs are more likely to be what? Compared with what? That's the direction of the relationship. Not just the vehicle type that is significant. If you can show marginal effects, that's more intuitive to show the 1 unit increase is associated with how much change in the response. That's very intuitive for us, for readers, and reviewers to understand your results. Okay, what's next? Discussion. Let's discuss the results, comparing with the previous studies. Are they consistent or not? Explain. If it's consistent, oh, that's good. Well, if it's consistent, then reviewers would say, well, if it's consistent, then why do I need to look at your study? I know previous studies. I don't need to look at your study. If it's not, explain it properly. Why? Then maybe you are showing something new in this subject, which is good. Always give examples when you discuss the application results, like who are going to use your results to do something. Give an example. Highway safety engineers may use your results to develop a countermeasure. What countermeasure? It's specific. Widening shooter, because your research shows that a wider shooter is associated with decreased crash frequency. That means the widening shooter is helpful. It's effective in reducing the crash numbers. Limitations, they are not excused. There should be objective issues that may threaten validity of the results. Maybe the sampling issue, non-random, under-reporting of observations. I'm going to show all those in my paper very quickly. Well, some reviewers would say, oh, you have not noticed something. You are not including something in your analysis. Well, that may be your scope issue. You may say our scope is limited to something. Okay, conclusion, summarize what I have done and what are study contributions, theoretical, methodologically, empirically, and practically. What are the key findings? Who are going to benefit from your research? How do they use the research results? Give examples. Always give examples. Continue research. Other tips, define and justify everything impossible. Don't just say you believe this is something. Justify something with reference. Use these references to support your opinions. Don't just say that's your opinion. Always use examples. When you write something. For example. Be brave and be focused. I said many times, be focused. And format matters. That's just to present your research, your papers in a very professional way. It's very disorganized. Well, that's not a very good impression to reviewers. General comments on your term project or research paper. Goals are not clear. Goals are not very well justified. You need to justify your goal. That means your goal is valuable. It's worthwhile to investigate this topic. Research question is not clear. What is the research question? No conceptual framework, so methodology looks vague. Are you convinced by your own results? Do they make sense? And writing is not focused. Again, focus. Okay, what's next? Yes. Okay, I'll just go very quickly with the paper. Spatial modeling. Why spatial modeling? It's just because the safety problem, the crash data, has a nature of the space. this is animation is basically showing you the location of the crashes, and also the height of those points shows the time when they occurred, when those crashes occurred in the day of time, the time of day. So it has the spatial and time nature for those crashes. So it's very reasonable to do the spatial modeling for the crash data, And also the data limitation is on observed heterogeneity. Spatial models, and because there are some factors like the driving culture, local policies, those factors are related to the space. If you do spatial modeling, those factors, the influence of those factors can be partially captured by the spatial modeling. So this is another motivation. This is showing the total crashes at gate crossings in the United States, and those are show the locations of those transpassing crashes. See those, clusters. Those clusters you just shoot. Like here, there are several transpassing crashes, but there is non-fatal crash. But there is a cluster, but there are also some fatal crashes. So that means there is variation, even though it's the same. You say they look at the crashes, the similar crashes, but the outcome is different. That means there's something we haven't captured. So we use the spatial temporal modeling. Just use spatial modeling to capture those unobserved heterogeneity. So comparing the spatial models and the traditional models. Traditional models outcomes the fixed relationships, which is all the relationships between factors stationary, the same size. But for the spatial modeling, different relationships from across different locations. So the size of all those data are different. For the traditional models, we often call global model because that is representing the overall relationships between the factors. But the spatial models, we are uncovering the local models. That relationship only represents the local relationship. And this is a kind of a process of doing the geographically weighted regression. And the outcome is we can find different categories represent different magnitudes of the coefficient, and how we're going to, because there are some space, there's no observation, but we also need to the relationships for those spaces. So this is the kind of, what's that? Inverse distance weighted interpolation, just interpolate to the results for those locations where we don't have our observations. And after that, we can have this continuous space, relationships between the factors. So this is just my paper, and I just very quickly to show some key. I think that's the paper. That's the paper. And abstract, introduction, literature review, and if I just search, for example, there are 8, for examples. Just when you say something, explain something, hey, for example, why don't you, for example? See, this is limitation, this is conclusion, like it's impossible within small regions that there are different relations across the sites due to the site-specific features. For example, the study find show that example. This is example. Cycling, this variable is an example. And non-stationary modeling estimates are valuable for prioritizing countermeasures for spatial region. This is given the recommendation how the practitioners are going to use the results. So now you, for example, a countermeasure is concerned with road user intoxication. The spatial attention is needed to region from Charlotte to Asheville, where countermeasure will be potentially reducing their severity. Give an example. Just give an example. Well, this paper does not have a conceptual framework because crash modeling is really just very simple. People know that. You always visualize the data. Visualize the data. Show the clusters because you want to say that there are some clusters in the crashes. Show it. Just don't just describe it. This is descriptive statistics. Show all those. This is because those are the categorical variables. We don't have the mean. We don't have the max. Mean is 0, max is 1. We don't have to show it. We just use percentages. And what else? Results, big tables, and visualize the results. this is the outcome of the spatial modeling. You see it's the same variable, which is the basically the age, but we see some this is young people compared with middle-aged people. Some locations where young people are less likely to be fatal in crashes, but some locations they are even less likely to be fatal. So that's the outcome of the spatial modeling. And I think I'm almost down there. And the last thing is because this one is already, this presentation is about crash modeling, but however, this is some other research we are doing recently right now. I mean, this is recently created by my students, Qifan Li here. This is also a way of visualizing results. I mean, when you show it, because we see all those activities in this region, this study is trying to capture how many people are going to use the shared autonomous vehicles when they are available in the future. We do need to know their travel demand, their activity performing patterns. So this is the way of just visualizing the results. So that's it. Thank you. And this is my team, and this is my website, and welcome to look through my papers in my website. So that's it. Any questions?
So I guess thank you so much for Dr. Liu for the presentation. I especially like the, for example, argument. I think sometimes when I read the paper, they just say, okay, we believe blah blah blah, and then like a couple of times I still don't get what they mean by that. But having the for example as examples, I think those will really connect you to the argument that they are trying to present. So I really appreciate that. And for members at the UT ITE and UA ITE, I think this will be a good great opportunity for you guys to raise a question, concern, or like even a challenge that you get stuck in the middle of a paper. If you have those questions, please ask them now.
Okay. Can I ask a question?
Yes.
Okay. Thank you. So first, welcome Dr. Liu, Dr. Li, and the students from the University of Alabama. And thank you, Dr. Liu, for sharing us the very useful suggestions and tips on the paper writing. And I have a question in regression model. Specifically, it is a regression model. For example, I saw you used the GWOL model in your paper, and besides in addition to this model, I also saw the other regression model in GWR, like GWPR, Poisson regression, and GWR. So why do you choose that model for your analysis? So could you give us some tips on the regression model selection? Okay, that's my question.
Oh, you asked the question about the selection of regression models?
Yes, right.
Well, first I need to ask what's your research question? What's your research question? Give me an example.
So very similar to your crash analysis. We also have the spatial distribution, like for example, like the cases, COVID-19 cases across the United States. We want to find what factors contribute to the different case numbers across the United States. So similarly,
I mean, your voice is not clear to me. I'm not sure it's my problem.
Oh, sorry.
Yeah, Yang Song, I think you need to get closer to the mic. But from how I understand you, I think Yang Song's question is about he's trying to model cases of coronavirus, and then he's trying to establish what are some of the factors that could contribute to, you know, changes in the COVID-19 cases. Is that correct?
Yes. Thank you.
Okay. That's a good question. But still, I just give you that tip. Be focused. Don't just say your research is about identifying factors associated with something. You have to be focused. Say something, is it tribal related, or is that something related, that factor is affecting the cases or something. You need to be clear, not just say, I'm not sure what factors are. Okay, if you are saying cases, and if your research is relational scale, I think that's the spatial modeling is very appropriate, because you may see some spatial variations of those cases coming up, even though given the same stay home order on wearing mask orders like that. But if you're modeling cases, that's the count data. So that we have to, now the research question is, the research scope is relation level, so spatial modeling, of course. And but now the data nature is that is count data. So the model needs to be able to model the count data. So that has to be something like a Poisson mixed binomial model. Then you cannot use an order model logic regression. It has to be count data modeling. But well, if you say that you are interested in the relationships between the cases and the factors, that means you are doing something about estimation. So you may not care about the prediction, so you may not have to go to the machine learning or something deep learning like that. So I'll just say geographically weighted negative binomial regression is appropriate.
Okay, thank you. And another question is that how was the last animation made? The last animation, how do you make that? What's the tool you used for that animation? Yes.
This is travel demand modeling. This the approach is the activity agent-based simulation. We first create a list of activities for each person. They have a chance of activities to perform in a day, and then we put them in the simulation. This modeling platform is called the MAXIM. It's Market Agent Translation Simulation Platform. And the outcome of the simulation is a list of the activities and events this person do. Every person does in this region, including the living a house, the entering a car, the driving a car, the living a car, the walk through a car. That's all events. So now using this platform to visualize all those activities. Those flashing dots. Those flashing dots representing the activities. The blues represent the staying home activity. The white dot is the activity, the work activity. I think some dots are for schooling activities, some dots are for shopping activities. They're just flashing up. That means the beginning of an activity.
Yes, really nice. Oh, thank you. Thank you, Dr. Liu.
And Dr. Liu, just to be clear, the software for this animation is called MAXIM, right? M-A-T.
This software is actually called VIA. But if you just search MAXIM visualization, it's the same. It will direct you to that.
Okay, yeah. Because I see the MAXIM in the name there, so just be yeah. So thank you, Yang-Sung, for the questions. Any other questions from our members and members from UA?
There is something Dr. Liu I want to learn other than reading your mentioned papers. Other guidance you might have in this regard. Oh yeah, I forgot to mention that doing this spatial modeling. Well, actually recently they have released something. Let's say GWR software. This is an old version of GWR. They have improved it to what is MGWR, and they have software for you to use it. You just download and you just put what is the Y variable, what is the X variable, and what is the what is it is logistic regression, it is linear regression or something else, but it's not very flexible. And I personally, I just use code. I just wrote codes in there, so I can switch from, any regression method is not just the links between X and Y. I can switch from this link to another link. So this brings more flexibility. So going back to again programming a little bit. You don't have to be an expert of computer science people, but still you can be very supportive and help you with your research.
So just to follow on that, this is actually my question. Is that I'm also like a PhD student, and then sometimes there are like some knowledge. For example, in this case, it will be the GWR, like something that I've never learned before. And then there's a debate, right? Like some students, they will say, okay, I have to take a course, in this area first before I can perform any work for my professors. Some other students may argue that once you get down to the work and try to perform a analysis, then you will learn automatically. Which side of the debate do you tend to agree with? Like, should students go to classes first, or they should just go into the research, and if they come across problems, then they try to solve that, through a course or asking their supervisor?
I just say, not just from me, just from me. I'll say both are important. Those statistics courses, they may not teach you how to build models like GWR, how to visualize the results, how to, I take that back. They may not teach you how to build a complete model in your research paper. They are just going to give you very simple exam models, but those courses are important to help you to appropriately interpret your results. Because I took those courses, and so I went through that kind of training process. And when I write a paper, I know how to properly interpret the modeling results, how to explain the situation, the phenomena in the data. In a very kind of proper way or professional way. But I review papers, and they may have learned something from just using a software or some code, just to borrow some code from somewhere else, just click to the data in the code and then run it and output the results and present the results in the paper. But if I look at their way to explain the model and the way to interpret the results, I can tell, okay, this guy or the author, they did not take the statistics courses because they are saying something very weirdly, very strange. So, but however, just to start working on a paper, building a model, that will help you getting the hands-on experience very quickly. If you have to, even though you are not very clear 100% about what is GWR and what is multi-level modeling, what is neural network, what is machine learning, but try to first of all duplicate what other people have done. Especially from the advisor, they may have codes, they may already have data. If you can duplicate what they have done, you have learned a lot. That will give you some hands-on experience, and now you use the knowledge you gain from the statistics courses to help you interpret the results, explain things in a very professional way.
Thank you so much.
So that's
Any other questions from the members?
Dr. Liu, I have a question. This is a great presentation. So, about writing the paper, I've seen the word focused a lot of times. And I understand this is one of the biggest thing, most important thing when it comes to writing a good paper. So my question, when you say focused throughout the whole paper, in a paper there are a lot of different components, like you said, introduction, literature review, methodology. At the end, it's conclusion. So do I have to be focused on what is the most important thing to be focused on? Is it about the goals and objective of this paper that I need to be focused throughout the paper, or the novelty of the paper that I'm writing on?
Focus on the objective. Focus on the goal of the paper. Focus
Okay.
on the goal of the paper. Such as well, I don't recall what's your dissertation topic. What's your dissertation topic? Can you tell me very quickly?
What? I didn't listen.
What's your dissertation topic? I forgot.
Well, now it's a connected vehicle system, so that's what I'm working on right now.
Well, you have to something. I think it's something about the signal, right? It's not just connected with.
We are trying to use trajectory information to control our signalized intersection rather than using traditional detection system.
That's right. That's I'm giving you example is, even though you're talking about a connected vehicle, but you are actually talking about it's a vehicle to infrastructure communication.
Yes.
So you don't have to talk about a vehicle or vehicle to other person in your writing. Just focus on the vehicle infrastructure, even though focusing on your specific kind of technique or your technology. And that's just an example for your dissertation. Like maybe you and your advisor will not agree with me. And if I go back to the crash papers, and we always, for crash paper to build crash models, there are like 30, 40 variables sometimes, but you have to focus on one or two variables. And if you focus on one or two variables, such as gender or age, now your introduction, you should focus on the age issue. Don't talk about other factors with about the safety. And all the literature review, don't say there are many factors associated with the crash safety, the traffic safety. Don't talk about that. Just talk about the age. Just talk about the age. Age is an important factor. Age. This research has talked about age in this way. This research has talked about it in another way. Age, only age. And then later your model can include many other variables, and you have to include other variables to have a complete picture of the crash modeling. But now your discussion start with the age, extensive discussion about the age-related factors, and for the other factors, briefly mention and say that the relationships between the crash severity and other factors are in general consistent with the previous studies. That's all. Another conclusion, and then the recommendation. Recommendation is also about the age. Don't just say, hey, it's surprising, and the wave type is kind of associated with, it has a different relationship with the crash severity. Don't say that, because your focus is not vehicle type. Yes. That is really distracting.
Yeah, thank you for the answer.
So I noticed we also have one question left in the chat. So I think we will. It's after 1 p.m. already. So I think we could probably take that question as the last questions.
Okay.
So the question is the difference between prediction and estimation.
Yeah, I saw that. William asked then about the prediction and estimation. So those two words are kind of from the statistics terms, and if you take those statistics courses, and if you say prediction and estimation, you can quickly tell the difference. So that is also, I say that's related to your focus, your outcome, your goal. Are you interested in predicting something, making sure your model can predict the outcome perfectly or nearly perfectly? So that is prediction. For example, what's important? Crash frequency, crash count. That is prediction problem. And something else like the stock price. That's prediction problem. We want to predict what is stock price tomorrow. We want to predict, but estimation is what? Estimation is like the investment, like what factors are affecting the stock price. So if we want to manipulate the stock price, you may need to work on those factors. Then you need to estimate the relationships between the stock price and those factors. And for the crash severity, we want to reduce the crash severity. We want to reduce the crash count, crash frequency. That's about estimation. What factors are really associated with the crash severity or the crash frequency? We work on those factors. That's the estimation. So prediction, you may not need to interpret the model. because that model can predict these things very good, in a very good way. So, okay, that's learn, that's deep learning, machine learning, neural network. Those models can predict the outcome very perfectly. So you don't have to explain. Those are black box. That's not for you to explain. But if you want to use a model to come up with some recommendations to reduce the crash frequency, reduce the crash severity, okay, now you have to explain the model. That means you have to estimate the relationships between the factors. So that's the difference between the prediction and estimation. So when you use it, I said that that's really based on your research goal. It's prediction or estimation. All right.
Yeah, I think that will wrap up our paper writing workshop today. Thank you again for Dr. Liu for taking your time to give this wonderful talk to the members from both universities. And I think